here is my Wayne Kerr, I better say this correctly, Wayne Kerr 6425 precision component tester, which it's basically an LCR meter, but they called it a precision component tester. Unfortunately, it's failed just while I was doing some precision measurements of some low value capacitors, which I needed for a diagnosis of a fault on a piece of equipment a client has sent me. This unit some years ago had a problem with CRT, and I replaced the CRT with a small VGA display and an RGB to HDMI converter, and really successfully got the display to look pretty much like it did with the CRT. So I had that working for quite a few years now, and it's been a 100% reliable unit since that conversion. Well, the other day I heard it just clicking the ranges because it was turned on, and I was over the other side of the lab, and anyway I went to use it, and then I noticed, oh, screen's blank. And I thought, that's a bit odd. And then the power light wasn't showing. So I switched it off, switched it on again, and the LCD VGA display came up briefly showing no signal. And I thought, well, that's odd, because the display uses the original 12-volt supply for the CRT. So obviously it looks like the 5-volt supply has failed, and I'm just going to open it up now and see what the cause is, whether it's a tantalum capacitor on one of the boards, or whether it's the main filter capacitor or a fuse. I don't know at this stage, but we'll find out fairly soon. All right, we're in. And as you can see over here, this is the LCD VGA display and the RGB to HDMI in there with an HDMI to VGA adapter just to plug in to the board there. I think we had to run off 12 volts. I can't remember. Yeah, yes. What we did was we took the 5-volt supply from one of the circuits in here to run the RGB to HDMI, and that's probably, and that would be logical why that didn't come up, but only the VGA display did, because if the 5-volt's gone, we've got 12 volts still for the displays. It looks like it's just the 5-volt supply that's down in this unit. Okay, what we're going to do now is just check the voltage across the filter capacitor, and we can get in there and see that we've got okay. We've got 1.6 volts and slowly rising, which is wrong. Well, let's have a look at some other field capacitors, and we've got 24 volts across that one. We've got 24 volts across that one, and we've got must be, yeah, so it looks like we've got minus 23 volts on that one. So the 5-volt is suspect. Okay, turning on the supply, and we're only getting 1.6 volts without the capacitor in circuit. So that sort of says to me that the power transformer, particularly that winding, may have failed for whatever reason, and I've still got to check out whether it's something shorting the winding on the circuit board. It may be a diode or something that's failed, but if it's a transformer, that's not good. We've got this board here, which has the bridge rectifiers for the 5-volt supply. So we've only really got the possibility of the winding in the transformer having gone open circuit, the diodes having failed, or maybe we've got some cracked solder joints on this board around the diodes. So the first thing to do is get this board out, and we've got a couple of Allen headed screws that we have to undo to get to release the board. And of course this is going to probably fall on the floor. Get my hand underneath there so that we can pull it out. And of course it's not going to come out. There we go. That's one. And the second one is down here. I'll undo that. Right. So now we've got the board released, and what we'll do first up is disconnect this wire, get that out, and you probably can't see this at the moment. Maybe I'll just check my camera angle. Yes, we'll move the camera up a bit. Now, so you can see this is the board we're removing, and I'll just put a little solder on the tip here to give us a bit of extra. And we can remove that wire. Okay, that's got that off, and then we have to, and actually some of these connections on here look pretty, they're pretty burnt by the looks. Now I just need a screwdriver. And where have I put my screwdriver? Oh dear. Maybe we'll try this one, which is a bit bigger than I'd like. And start getting that one's lifted out, and again you can see that there's some burning on that connector, so there's obviously been a bit of corrosion and or a bit of excess increase in resistance, so this is burnt. And similarly we have to get this one out. Okay, that's that one. We've got a small one here, which you should be able to push through. Yep, there we go. And then finally this one here, which we'll push through as well. And then, of course, the system connections are in a completely different connector on the other end. So what we need to do now, if I try and angle this so you can see it, this pin here and this one, which is the one we used a direct wire connection to, but this one is pretty manky looking. It's been overheated. Interestingly, it D0 where are I? I've got to read these. I'm pretty sure that's, yes, D01, D02, D03 and D04 are the bridge rectifier for the 5 volts. So what we shall do now is just check that these diodes are okay. All right, we're on diode check, and 1 point. Okay, so that must be the, not sure which is the cathode end on these because there's no apparent designation, but certainly this way around. So cathode's this end, we're 4.37 volts, and we're 4.37 volts there. Oh, okay. The silk screen has got, oh, wait a minute. That's very interesting. The marking on the silk screen is the opposite way around those diodes, and we've got the same. That's okay. Oh, that's interesting. Okay, that's all right. So if we believe that, that's cathode that end. All right. And that should be cathode that end. Yes, and if we go that way around, yeah, that looks better. And I think we were shorting underneath here, so so we said cathode, so that should be cathode. Yes, we go the other way around, and that's a higher voltage, and that should be cathode, and we go that way around, and that's right. So these appear to be okay. So the next thing we've got to do is have a look at the continuity of the winding, and I'm guessing, I'll have to refer back to the manual, but I'm guessing that those two, well, what we'll do, we'll go for continuity and just see whether we've got continuity across those pins. What about those? Oh, wait a minute. Let's just, so I can't, I don't think I'm getting in there close enough. That's not appearing to be very good. So let's try and fit a piece of wire down in these and see if we get any continuity of that. Just try and get something in here to see. That feels pretty loose in there actually, quite loosey goosey. So I'll try and get this side out. All right. So let's just go this way around. I'm really not sure at this stage whether we're getting good contact or not. Maybe that we'll have to try and spring these out of the connector. Now, let's grab some wires so we can just easily hook on our input supply. And we get AC on here, AC on there. Make sure they aren't short, turn it on, and we've got 9.9 volts. So we've got a continuity problem across. Oh, that's interesting. What? Oh dear. Okay. Well, that's starting to get a bit dodgy there. Maybe it's the crimps themselves. No, that's come good. It's probably not, but that's 10.3 volts now, pretty solid. And I can't, just moving that, I can't get it to do anything. So 10.3 volts AC. So it looks like it's a corrosion come heating problem in that connector. Well, we've either got to try and get a connector to replace it or whatever. So at least that gives me a bit of relief that it's not a transformer winding. As you can see, there's been some localized heating on the end of this connector, and obviously what's happened is there's been some corrosion or whatever, and the resistance between the contacts in the connector have increased and further or caused the heating and also further caused damage. And in fact, I don't know if you can actually see it. I'll get my finger near here. I might have to put this under some magnification, but there's the on the side that makes contact on this crimp, there is some pitting. I think there is a similar amount of pitting on the post that forms part of the connector that's on the circuit board. So yeah, this is the problem with the unit, and in fact you can also see on this other connector there's been heating, and in fact that is the one that I actually physically connected another wire across to the circuit board rather than relying on that connection some years ago. So yeah, so it's not particularly good, and it's only supposed to be about 3 amps maximum, because that's the current limit of the regulator. But obviously corrosion and causing increase of contact resistance has actually caused the heating to occur. I've got to try and find a replacement for this connector, and so far I've not been able to find a suitable replacement that I'm happy with. So in fact, what we're going to do is use a pluggable terminal block which has a lot higher current rating but has the same footprint, and we'll actually mount a right angle socket so that it comes out of the edge of the circuit board, and then we can come back here and we'll put bootlace ferrules on these, and they can be screwed into the terminal block, which can then be in total plugged into the circuit board. But I'm waiting for the right terminal block to come from our suppliers. That seems to be all the issue really is, that it's just stopping the 5-volt rail from working properly. Seeing I was unable to get the original, I presume they were Molex or some other type of header that was used in here, instead I've used a right angle board mounting plug which allows pluggable terminal blocks to be installed. We've used bootlace ferrules on these wires for a good gas tight connection. This also should have better current handling capacity, certainly for the 3 amp supply, or near on 3 amp supply for 5 volts. So let's just turn her on and see what we get. Okay, power lights come on down there. We've got a splash screen from the RGB to HDMI, and we've got a working display, and I'm happy with that. So looks like our LCR meter's working once again. Now, just a minute ago I mentioned bootlace ferrules. I don't know if any of you know what a bootlace ferrule is, or if you do, that's well and good. If you don't, what it is basically a sleeve that you crimp over a stripped end of wire, so that that can then be inserted into a terminal block and screwed down, rather than directly bearing on the stripped wire. In instrumentation and low voltage stuff where corrosion can be your enemy over time, this is standard practice that a lot of people use. And I have a story about this actually. The company I worked at, we had a guy who came in, he actually was appointed over me as the manager of the department, but he was more a sales and marketing guy, but he thought he knew how to design product. And he got a job to quote on. He underquoted it. Anyway, near the end of the job, one of my technicians came to me and said, look, he said we shouldn't be using bootlace ferrules because we haven't got enough in the budget for it. And I said, what? I said, okay, let me have a talk to him. And I said, look, you know, the system's going to fail out in the field, and that's our company's reputation on the line, you know. So he had none of it. No, I can't afford the cost of putting in the margins that tight, blah, blah, blah. So I said, okay, fine, be it on your head. And anyway, within a day or so, we had a type test with inspectors from the government department that was buying this equipment. And lo and behold, the equipment failed on test. And anyway, I said, no bootlace ferrules. And the managing director, who was there at the time as well, turned to me and said, what, Peter? And I said, didn't have bootlace ferrule installed, which is our standard practice. And he turned to the guy and said, look, you do everything that Peter directs you to do as far as getting this system right. I don't care what it costs. And the guy just looked very sheepish and sort of walked away. So we did the changes to it, and the equipment survived, I don't know, must have been about 20 years or something, because we never had any call from the customer back to say there was a problem with it. So I was actually vindicated because the guy had made stuff ups on a number of other jobs anyway, so it just proved another part of his incompetence. Anyway, rant over. But just remember, if you're wanting long-term reliability on screw terminal connections, use bootlace ferrules of appropriate size for the wire that you're trying to fit into the terminal block.